So our next speaker is Dr. Erick Sperandio. Yeah. So Erick is associate professor in AI for clean air at the Surrey Institute for People-Centered AI. He's a member of the Global Center for Clean Air Research, GCARE, and Sustainability Fellow at the Institute for Sustainability. He leads program in AI for sustainability within AI and Institute for Sustainability. Uh, Previously, he was in also in Cinematic Brazil, associate professor, and as he already mentioned, he's a university ambassador of the NVIDIA Deep Learning Institute. So please welcome Erick. Yeah.
Thank you, Dr. Arshdeep. Well, morning everyone once again. Today I'm going to quickly try to present to you what we have been doing here at the University of Surrey towards AI sustainability. So how have we been contributing to the AI sustainability area in terms of research and technology development? Okay, okay, we have been talking about by this time what AI sustainability means. So here in the University of Surrey set out our AI sustainability program. So we want to answer those questions. So how can AI contribute to achieve the UN Sustainable Development Goals? So for this, we think that's fundamental for us to develop an approach that can put people and the environment at the very center of everything that we are going to develop, not only here in the University of Surrey, but beyond. So, so when we talk about AI sustainability, we are actually talking about a coin with two different sides. So one side of this coin is the sustainability of AI, or many times also known as sustainable AI area, which means the area that we are trying to develop in and making AI development more sustainable. So usually we are talking about how we can make AI development more energy efficient. So we have been seeing lots of talks here, wonderful talks about this. Also, how can we develop AI models with less data, but with better data, so data efficiency? And how can we make AI more trustworthy? So for example, how can we make AI models more interpretable, more explainable? How can we deal with bias and unfairness in machine learning models in era that we have been witnessing lots of automated decisions took by AI models that are many times present some kind of prejudice. So how can we detect and also mitigate those bias and fairness that might arise from AI models? So also, how can we train and how can we better train and educate people to use and to work with AI, to avoid more job disruptions and things like that? So this is one side of the coin. So the other side is about how can we develop AI solutions, novel or even traditional AI solutions, to foster sustainable development, to achieve sustainable development goals as a whole. So how can we, for example, use AI for clean energy generation, for clean air, for climate change, for extreme weather events? So, for example, the wonderful works that Jeff and the NVIDIA have been developed so far in this area, for health and well-being, for social sciences, and etc. Also for smart manufacturing, many other areas. So as we look into the 17 SDGs, we are trying to see in a holistic way how AI can be really developed and applied and employed to help us achieve the UN Sustainable Development Goals. Also, we want to, by doing this, we also want to foster the development of good standards that bring us towards the Industry 5.0 and Society 5.0 standards. So when we talk about Industry 0.0, of course, it's a very new term, but it's building upon the concepts of Industry 4.0, where we work with cyber physical systems. Here we are trying to make the industry development and also the technology development are focused on the people and also environment to make the development more sustainable, not only in terms of the environmental sustainability, but also the social sustainability, and how we can make them all together working in a more sustainable environment. And also it talks about the Society 5.0 as inside this whole concept. So by working within this AI sustainability program, we want to help us not only as academics, not only our university institution and community, but also beyond this, external stakeholders like the industry, other academic institutions and colleagues, and also the society as a whole, to contribute towards having a more sustainable development and how AI can contribute to this in those different ways. So here we have set out our AI sustainability program, in which we are trying to contribute to achieve those sustainable development goals. So here we have, for example, the sustainability angle of our AI sustainability program, where we are worried about how we can develop novel sustainable AI solutions to, for example, achieve to reduce CO2 emissions, to have faster inference, to reduce memory resources and train and deploy the AI models with more efficiency, but also how can we train and educate people to work with AI, how to make them more explainable, interpretable, and how to make our AI solutions more ethical and trustworthy as a role, and etc. And also at the other side, how we can use AI to help us, for example, tackle challenges within smart manufacturing, cities, infrastructure, and homes. Also, how can we use AI to help us have cleaner energy, air, and water? How can we use AI to foster entrepreneurship? How to also tackle extreme weather events and to mitigate them, and to achieve net zero targets for food systems, and also to fight climate change. So this is just to present a little bit of my background. So I'm associate professor in AI for Clean Air Systems, and also the program leader of AI and sustainability. I'm working with many areas within this domain. So, for example, have been working a lot with sustainable AI and also trustworthy AI, fundamentals of AI as a whole, foundation models, including recently foundation models for atmospheric sciences to tackle sustainability challenges, and also with quantum AI and quantum machine learning, and in many areas within AI for sustainability. So, for example, using AI to predict extreme weather events. I'm going to present some case studies to showcase what we have been doing. AI for health and well-being, AI for clean energy generation, for air pollution forecasting, for predictive and prescriptive maintenance, and many other areas. Within our program, we have set out our core research areas. We have more than 50 fellow researchers across faculties within our university. And within our program, we have those core research areas in our co-leads. So we have model and data efficiency, which is co-led by Dr. Arshdeep Singh. We have also trustworthy AI, which is co-led by Dr. Alireza, and clean air, AI for clean air, led by Professor Prashan. AI for clean energy, co-led by Dr. Liang Chui. I think she was here. She's not here anymore. Also, AI for clean water, Dr. Devendra. AI and governance, Dr. Feja. She's over there. Please raise your hand so everyone can know you. Great. AI for decision support and optimization, Dr. Michael Short. AI for circular economy, Dr. Lei Xing. And AI in social science, Dr. Jill. She's over there as well, and she's going to present the next speech right after me. Okay. So just a little bit about some of our core research areas. So in the AI for clean air, for example, we have been researching how we can use data-driven approaches and also physics-informed neural networks. As Jeff explained, the idea is to constrain the training of those neural networks, we're using the physical knowledge, the physical equations of the phenomenon that we want to reproduce and to simulate using AI, so that we can have models that are not only similar to those current approaches that are using, for example, state-of-the-art in numerical modeling, for example, but with a fraction of the computational cost required to run them. So this is the main idea behind this. So we are working with emissions inventory, grid simulated data. So for example, data from global data assimilation system from NOAA in the US, and also from ERA 5 from ECMWF in Europe. Satellite data, and then surface observations to then enable us to achieve models that have good accuracy, good performance, and also are very fast to run. By doing this, we are not only contributing to better forecast air pollution, but also contribute to have more sustainable models, so that, as for example, as Jeff presented, they can run very with a very wonderful speed up efficiency. And the other core research area that we have is the sustainable and efficient green AI, which is co-led by Dr. Ashdev Singh. Of course, he would be able to present this in a much more straightforward way than myself here. But here we want to make AI model more efficient as a whole. So how can we take those AI models and develop them so that they can run in a much faster way and reduce their energy consumption, their energy hungry, while running, not only during training, but also during inference time. So here we are studying ways to compress AI models, for example, using pruning, knowledge distillation, quantization, and a combination of them, so that we can take, for example, pre-trained models and use them for downstream tasks, and then to embed them into low computational hardware that are much more energy efficient, but they have also lower computational resources. So how can we achieve this? So this is the purpose of this core research area. Also, we have the AI for clean energy that is co-led by Dr. Liang Chui. The purpose here is to study and develop AI solutions that can help us to better predict the generation of renewable energy production, and how we can combine them in an optimized way so that we can take the best of those combinations. For example, we know that wind energy, for example, is an intermittent source of energy, right? So we cannot store wind. So then it's very difficult for us, for example, to predict the wind in the short term, because it has a very turbulent nature. So usually numerical models, those are the state of the art in this area. They have some difficulties on simulating the behavior of the wind, even with very high resolution. And as we improve the resolution, it becomes very difficult for us to run them, because their computational time is really bigger than when we have low resolution grid simulations. So with AI, we are able to simulate the behavior of the wind for short and long-term predictions with a fraction of the computational cost. So this is the motivation of using AI for this area. And actually, it has been very successful for this purpose. Also, another area that we have is the AI for decision support and optimization, which is co-led by Dr. Michael Short. So here, the idea is to enable us to use AI as the means to optimize complex systems, so that we can get the best of them and simulate different scenarios and get the best possible scenario given the constraints and requirements that we have for a certain problem. The other area, which is co-led by Dr. Jill, she's going to present much more about this later, is how we can use AI to improve and to to enable us to better understand social dynamics. So in areas like sociology, business and management, economics, politics, law, hospitality and tourism management, literature and languages. So we are working with AI for circular economy. The idea is to enable us to have an optimal material energy flow and closed carbon loop and zero carbon emission using multiple electricity supply and also green energy. So it connects with other core research areas, using AI to optimize the whole system to enable us to better predict the generation of different types of energy sources, and also how we can achieve circular economy targets using artificial intelligence in a holistic way, so that we consider not only business aspects, but also social aspects and sustainability aspects, of course. So here I'm going to quickly present some case studies that we have developed so far. Some of they are just some projects that we developed so far, so that we can showcase how AI can successfully be applied to tackle sustainability challenges. So one is, for example, this project that we are working with. The idea here, as we have large deep learning models, in this case applied for predictive maintenance, we want a way to take those models that are running usually in the cloud closer to the sensors, so that we can not only make them work in a more secure way, so that data is not going through the whole network and avoiding any type of data loss, and also dealing with privacy issues, but also to enable those models to run in very limited hardware setups, but still with a very similar performance for those when we compare with the large versions, the baseline versions. So here we are taking those models, these pre-trained models, and we are compressing them and testing them in different types of microprocessors units for deep learning on the edge. So for example, we are working with Arduino Nano, SparkFun, STM32, Raspberry Pi, NVIDIA Jetson Nano, and NVIDIA Ori Nano, to name a few. Then we are working with quantization, pruning, knowledge distillation approaches, and a combination of them to achieve the state-of-the-art results, and then also to contribute to the current state-of-the-art, so that we can also enable other researchers and practitioners to use those techniques to compress large models, and then to enable them to be run in very limited hardware setups. Also, another project we have been working with is we developed this transformer-based architecture with wavelet transform for better forecast wind power generation. Here, the basic idea is to leverage the transformer architecture, which is the one that's powering ChatGPT, for example, right? Which was the game-changing architecture for natural language processing that we are witnessing nowadays. And here we adapt this transformer architecture for this purpose. It just not present the similar results at the state of the art, but also were faster to train when compared to traditional deep learning architecture. So it not only contributes to the sustainability, but also makes this AI more sustainable, because it's faster to train than other deep learning architectures. Another project we also worked with, we used a data-driven approach. In Brazil, in this case, we applied, we ran a WRF model, which is one of the state-of-the-art weather forecast numerical models for a region in Bahia, in Brazil, which is Bahia in the region of the northeastern region in Brazil. Its size, it's comparable to France and Spain, just to present to you an idea of the size of this state in Brazil. And here we train some AI models and compare the results with a fine-tuned WRF solar model to enable us to forecast solar radiation and air temperature. So then we would be able to predict solar power for generation. So we trained the models for 4 different cities and test the model in an unseen region here, but also in another region here in the north part of Bahia. Then our results showed not only that those models were able to achieve similar performance than Warp Solar, but also superior performance, but with a fraction of the time required to run the numerical model. Once again, as Jeff just presented, that is a very important application and opportunity to use AI for this kind of modeling. Here we used AI to create AI surrogate model to simulate the production of hydrogen using a proton exchange membrane electrolyzer. So just to summarize, we achieve superior performance than the state of the art. Mohammed, my PhD student, is working with it right now, hopefully finishing the paper by the next few weeks. So here also we present a good opportunity to use AI to create those surrogate models because physical models usually take much more time to run. So in this case, we are applying AI and creating a surrogate model that runs with a fraction of the time required to run the corresponding physical model. So just to speeding up because the time is running out, here we use AI to forecast air pollution for the two different sites here in Guildford City, where the University of Surrey is sitting. And also we compare different types of neural network architectures, achieving also a good performance when we use feature augmentation powered by wavelet transforms. Also, we applied AI to forecast extreme weather events. In this case, it's an application to forecast lightning events. Forecasting lightning is very difficult, even if we work with state-of-the-art numerical models. But in this case, we are working with global data simulation system data, and we got access to a very important data set in the same region of Bahia in Brazil. And we developed a novel architecture that enables us to achieve superior performance than we compare with the current state of the art for lightning forecasting. Also, we worked a lot with also different types of projects. For example, in here, we are working with how to identify and mitigate bias and fairness machine learning models. My master's student, Rafael, is working with me, among others, in this area. Very quickly, also, we work with AI for health. So during the pandemic, we developed two deep learning models to support the diagnosis of COVID-19 by looking at chest X-ray images and also lung CT images. And this was very interesting because we were able to apply those models to be used by the public health system in Brazil to support the doctors during the pandemic, to fight the pandemic. Here we use also deep learning to predict the behavior of the pandemic for more than 180 countries in the world. For the next 30 days, we trained the model for 2020 and test the model with data 2021. And then we were able to compare with the current state of the art. And then we showed here how also deep learning can be used to model those unseen events and to help us to fight this type of scenarios like we faced during the pandemic of COVID-19. And just to finish, we also work with AI for smart manufacturing, in this case, for predictive maintenance purpose. Here we developed an AI model that was able to predict when an HPC system would fail using advanced techniques, so contributing to have more resilient and higher technology industries. And also here we work with self-supervised deep learning approach using multivariate time series to also support us to classify failures in machines for smart manufacturing purposes. So just to highlight, we here compared a baseline approach using fully labeled data sets. This is the area under curve precision recall curve. Just to show to you the baseline model using 100% of the labeled data set, and our approach that didn't use any labeled data, just fully unlabeled data set we achieved very similar performance, 96%-ish, showcasing the importance of working with AI to also enable the sustainability and resilience of the industry. So this also talks about how we are using AI for food systems and some ongoing projects, just to highlight that we also are working with, for example, foundation models for foundation physics informed models for time series forecasting of atmospheric phenomena, and also with quantum machine learning for sustainability challenges. This is it, some references, and thank you so much for your time and questions if you have.
Thanks, Eric. So we have time for 1 or 2 questions. Questions from the room? Yeah. Please. Okay.
Good.
Yeah. Do we have any? Yeah. There's one. Yeah.
So here at the university, you're bringing together 2 very broad things, one focused on AI, one focused on sustainability. How are you actually going to get the people to talk to each other in these different areas?
So that's the whole purpose of, for example, this workshop and the program. Actually, within our program, we try to bridge the gap between AI world, which is very broad, and sometimes people are not paying too much attention of the sustainability part, and also the sustainability angle, which many times people who are working with the sustainability part not so much aware of what AI can do. So by bridging these 2 different worlds together, the purpose of our program is actually to have an interdisciplinary team to discuss and to understand the opportunities and also to collaborate around this area so that we can develop further these 2 areas together.
Yeah, we have one more.
Thank you. Very interesting work. So the current AI paradigm is very much statistic and big data driven, and in my opinion, not very sustainable. Could there also be an input to change the whole paradigm to the more cognitive AI, which is much more energy efficient and doesn't require so much data, these data centers which require megawatts of power and all that?
Yes, that's a wonderful question. Actually, one of our main purposes to really enable us to have more sustainable AI techniques so that we can not only have smaller architectures that have similar performance than those very large, because the large